Hey everybody, welcome back. This is part two of the first assignment about the Gusev crater, which is a combination of thinking about deltas and also thinking about geologic maps and the process that we use to make them. So what you're looking at on screen right now is a US Geological Survey geological map of the Gusev crater region. And I am sure you are thinking, that is nuts looking. Um, but it does actually look a little bit similar to the other bedrock map that you looked at of Mars. You can see the younger craters are again in like sort of a lighter color, this yellow. You can see some older crater and the ejecta blankets are in green. Gusev crater is actually here in the center. It's a large crater. It's fairly old. It's got smaller craters inside of it. And this was an area that a rover was sent to in 2003. It landed in 2004. It was one of a pair of rovers that actually were launched at the same time and went to different parts of the planet. The one that landed here was Spirit. It was only designed to last for 90 days, but it actually ended up communicating for about 5 years. So it was pretty amazing. The other rover, Opportunity, started recording also in 2004, sending back data in 2004, and actually didn't shut down until a planet-wide dust storm in, I think, 2018. So that pair of rovers drove a lot of science. And Gusev Crater Spirit has been a pretty interesting story. So let me show you, we're going to move to the Google Earth image next so we can see a little bit why people were so interested in this. So you can see here's the outline of Gusev crater. Again, it's an older crater, so the crater rim itself is sort of degraded. You can see it's got the rover landing site marked and some of the track information. What initially drove a lot of interest in this crater was that it looks a lot like the other location we were looking at in the first video. So there's a large crater that would have been a quiet basin. There's a meandering incised channel leading into it. And there are these formations down here in the southern part of the crater, and we're going to take a closer look at those. So from the imagery that was available in the late 90s and early 2000s before the rover was launched, this was the area that really people were looking at and interpreting in a very specific way. You can see the fluvial or the river channel coming in. You can see something that looks like it might have at one time been sort of fan or arc shaped. And you can see that it's got a relatively flat top and sort of a steep front. So when people looked at that, based on their visual characterization, they gave this deposit and also this material over here to the northeast of it, also along the side of the crater. They made those one geologic unit. And when we go in and we look at it a little bit more carefully, they labeled it AHBM1 and gave it this kind of teal color. And the AH, when you have the two capital letters, that means they're not exactly sure about the geologic age. So they're assigning this to both the Amazonian and the Hesperian times. They just don't know without more information. These little tick marks around the edge of the units, that means that it's got a steep side. That's all that it's telling you. So they put that on geologic maps to show where there are sort of steep bluffs or cliffs. The way that this was interpreted shows up in the legend for the map. So here's the overall or a piece of the overall map legend. We are looking at this light green in here. So it's not the youngest deposit out there and it's not the oldest material out there. It's sort of in the middle. Um, and we're going to look at this area in detail. It's in what was called the basin floor assemblage. So let me just show you what it looks like. So here's this teal green again. Here's that zoom in on the map. And it's AHBM1. So when we go look at the description of this, it says that it's rugged surface with small hills, moderate albedo. They talk about that a lot in their descriptions. And the interpretation is that it was a fluvio-lacustrine sediment formed during widespread ponding inside Gusev by flooding from Madam Vallis and Durius Vallis. So the really key thing here, this fluvio-lacustrine sediments formed during widespread ponding. So fluvial meaning river, lacustrine meaning lake. This was basically assumed to be a delta deposit and or shoreline deposits associated with a delta. And this was based on it having what was perceived as sort of an arcuate shape, a flat top, and maybe a relatively steep front. I think the idea was when they were looking at this is that they felt that maybe it had, after it had been deposited and as water levels were changing, that maybe it had gotten incised or eroded in between pieces of it. And that's why it was sort of disconnected now, so that these were sort of remnant pieces of a delta that were left here. But this was based on, again, the flat top, the arcuate shape, and this was used as evidence for making a really strong case to send a rover here because they felt like this small crater lake would have been a really quiet environment and it would have been perfect for finding maybe early signs of life. So, so that's where all of this stood when the rover was sent there. And next week, we're going to take a look at what we actually learned from putting the rover on the ground and how that's changed the geologic map of the area.